Most electricians use grounding and bonding like they mean the same thing. They do not. The NEC defines them differently. They serve different purposes, and the Florida EC exam tests whether you know the difference. If you confuse these two concepts on the exam, you will lose points on one of the highest weighted sections in Article 250. Here is the difference, straight from the 2023 NEC. Grounding connects the electrical system to the earth. That is it. Article 100 defines grounding as a connection to ground or to a conductive body that extends the ground connection. The purpose is in Section 250.4. A.1. Grounding stabilizes voltage during normal operation and limits voltage from lightning strikes and line searches. The physical connection is made through grounding electrodes, listed in Section 250.52. Ground rods, metal water pipes, concrete-encased electrodes, and ground rings. The conductor that makes this connection is the grounding electrode conductor, sized from Table 250.66. One thing grounding does not do, it does not clear faults. Earth cannot carry enough current to trip a breaker. That is a common misconception and a frequent exam trap. Bonding connects metal parts together to create a low-impedance fault current path back to the source. Article 100 defines bonding as connecting to establish electrical continuity and conductivity. Sections 250.4, A.3, and A.5 work together here. Bonding connects non-current carrying metal parts, and the fault current path must have low enough impedance to trip the breaker. This is what actually clears a ground fault, not the earth connection, not the ground rod. The bonding system. At the service, the main bonding jumper connects the grounded conductor, the neutral, to the equipment grounding conductor and to the enclosure. That connection is what ties the grounding system and the bonding system together in one location, inside the service panel. Everywhere downstream from that point, it is the equipment grounding conductor that provides the fault current path. The equipment grounding conductor is sized from Table 250.122, based on the rating of the overcurrent device protecting the circuit, not the ampacity of the conductor. For a 20-amp breaker, Table 250.122 requires a minimum 12 AWG copper equipment grounding conductor. For a 100-amp breaker, it requires 8 AWG copper. One rule many electricians miss. Section 250.122b says if you upsize circuit conductors for voltage drop, the equipment grounding conductor must be increased proportionally as well. The exam tests Table 250.122 directly. Know the table, know the sizing method, and know the 250.122b upsizing rule. Here is how to keep them straight on the exam. Grounding goes to earth, voltage stabilization and surge protection. Bonding connects metal to metal, fault current path that trips the breaker. If an exam question asks what clears a ground fault, the answer is the bonding system and the equipment grounding conductor, never the earth connection alone. If it asks about voltage stabilization or lightning protection, that is grounding. The Florida EC exam tests this distinction in multiple formats: definitions, sizing, and scenario-based questions. Know Section 250.4, and you will have the framework for all of them. If this breakdown was useful, subscribe. Every video on this channel is built around the 2023 NEC and the code you are actually being tested on.